if you need to solve some sort of equation with matrices, you should know something about inverse matrices. So if you haven't learned about that, you can go find that video. But solving this equation, we need to get x by itself. We need to find out what the answer matrix is. So just like any other equation, we'd like to get rid of this, because that's not helping us get x by itself. So how are we going to do that? You could just subtract it from both sides of the equation. Because this, subtracted by this, gives you the 0 matrix, and anything plus 0 is itself. That's an identity. So this will be eliminated, but what we do to one side of an equation, we have to balance it out by doing it to the other side. So hopefully you've done matrix subtraction before. It's pretty straightforward. Just subtract the symmetrical elements. 5 subtracted by 2 gives you 3. Then you get 5 subtracted by 6 gives you -1. 5 subtracted by 18 gives you -13. And then 5 subtracted by -12, that's actually adding. So that gives us 17 over on this side. And what's left over here is this stuff. And the x matrix that we don't know. So it's smaller. Still need to get x by itself, so this has to disappear. What we're going to do is we're going to find the inverse of this matrix. Then we're going to multiply that inverse to both sides, because when you multiply a matrix by its inverse, it gives you the identity. And the identity times any matrix is itself. So it's like we're getting it by itself by multiplying it by the inverse. So let's go find the inverse off to the side here. Let's do it in blue. So here's the little formula for finding the inverse matrix. So if we follow the formula, we first need the determinant. And the determinant is found by doing these guys, cross-multiplying, subtracted by these guys, cross-multiplying. So we got an inverse of -2. And this is a sub 2. Oops. The formula says that A22 needs to be placed first. So that's row 2, column 2. This is A12, so that's row 1, column 2. That needs to be negative, but it's a 0, so 0 is neither positive nor negative. So this one is the same, it just needs to be negative again, just like it's diagonal. And then we need a -1 down here because it says A11. So when we multiply this out, the -1/2 times all the elements, you get -1, 0, 7 over 2, and 1 over 2. There. So we have our inverse. What you want to check is take this guy, multiply it to this guy to make sure it's its inverse, but it is, I think. So here's where we were. So I've taken that inverse and I multiplied it to the left side on each equation. It's important that you keep track of which side you're multiplying it to. You have to keep it balanced by multiplying it on the left side. You get a completely different and wrong matrix if you multiply it on the right side. So make sure if you have to multiply on the left to make it disappear over here, you multiply on the left on this side. So this is going to go like this, because you've multiplied by the inverse. But when you multiply this side over here, that's going to give you your answer matrix. So the first element, we got -3 plus 0. Second element, we got 1 plus 0. Third element, we have 21 over 2 subtracted by 13 over 2. It gives us 8 over 2, so that's a 4. And then the last one, you have -7 over 2 plus 17 over 2. That gives you 10 over 2, so that should give you 5. If you had trouble with what I just did there, then you need to practice multiplying matrices. There should be a video on here somewhere for that. This is your final answer.